Welcome. In this video, we'll talk about using the derivative of an exponential function. And here I want to start by just reviewing some of our basic rules that we know about differentiation. We need to be sure that we make a distinction between a power function and an exponential function. A power function is a function that looks like f of x equals x to a power. In other words, the variable is the base and the power is a constant. Power functions have a special derivative rule, the power rule, that when I take a derivative of x to a power, the derivative function is that power times x to the power minus 1. An exponential function is different. Here the function has a form f of x equals some number to a power x. So this time the base is a constant and the exponent is the variable. Now that base has to be greater than 0 for an exponential function to be defined. We learned that the derivative of an exponential function is the same exponential function times some constant, where that constant is defined by a limit that came from our definition of a derivative. It's the base to a power h minus 1 all over h, and that limit h goes to 0. The natural base e is a special number so that when I do this limit, I get the value 1. And the consequence of that is the derivative of e to the x is itself e to the x. Well, from these two derivative rules, the power rule and the exponential rule, we can generalize those and get general power rules and general exponential derivatives using the chain rule. So here, u represents any expression that is itself differentiable, so that if I have the derivative of some formula to a power p, where p is a constant, I get p times that formula to the power p minus 1 times the derivative of what that expression was. I think of that as the derivative of the inside. Alternatively, for an exponential, if I have e to a power of a formula, where the formula is not just a variable, I get, remember, the derivative of e to the x is itself, so the derivative of e to the u is itself times the derivative of what was in the exponent. Let's look at two examples of how we use these rules. I've got two functions. I've got e to the x plus 3 all raised to the fourth. I want to take its derivative. And I also have e to this quadratic x squared plus 3x plus 1. And I want to find out how to take their derivatives. Both of these involve the chain rule, so let's illustrate how we would do that. For the chain rule, I want to think about what's the inside formula and what's the outside formula. And here, my inside formula, my u is e to the x plus 3, and my outside formula is I take that u and raise it to the fourth power. Now I want to look at each step in the chain, and if I can calculate their derivatives, so here's the chain, my derivatives, the derivative of the inside is, well, e to the x, its derivative is e to the x, and the derivative of 3 is 0. I add those, I get du dx is e to the x. And the derivative of the outside formula, dy du, this is a power, u to the fourth, so its derivative is 4u cubed. Those are the derivatives of each step in the chain. So when I want to talk about what's the derivative of the entire composition, I'm going to think about the function that I'm taking a derivative of. I'll call that f of x. And so the derivative of f of x is going to be dy du times du dx. My derivative, dy du, that's the derivative of the outside formula, is 4 times u, that was e to the x plus 3 cubed, that's my dy du, times du dx, which is e to the x. And so my derivative, let's write that as 4 times e to the x times e to the x plus 3 cubed. And that finishes the first example. Let's now go to the second example. The inside function is what's inside the exponent. And so my inside function is x squared plus 3x plus 1. And my outside formula, y, equals e to the u. This is my chain. And the derivative of each step in the chain, the derivative of u with respect to its variable x is, well, x squared's derivative is 2x, 3x derivative is 3, 1's derivative is 0. And the derivative of the outside function, e to the u, its derivative is itself. And so if my function that I'm taking a derivative of is e to the x squared plus 3x plus 1, its derivative is dy du times du dx. In other words, my derivative is e to the u, so e to the same thing, x squared plus 3x plus 1, times the derivative of u, which is 2x plus 3. And this is the derivative of my second function. This is how I can use the derivative of an exponential and the derivative of a power in their general forms using the chain rule.